Assalamualaikum warahmatullahi wabarakatuh and a very good day to everyone. So now let's continue with our tutorial of functions and graph. So for today's discussion, we'll focus on how to show that a function has an inverse and we want to find the inverse of the function. So let's start our discussion for number 7. So let's say you are given fx and you are given gx. And then we want to show that f is one-to-one function and we want to find the expression for f inverse. So you are given fx equal to 2x plus 3 squared minus 5 where x less than negative 3. So to show that this is one-to-one function or not, so you have two ways of doing that. So the first method is you can use algebraic approach, and the second method is by a graphical approach. So you have to sketch the graph and then you do horizontal line test. Okay, I'll choose second one. So I want to sketch this graph first. Okay, so since this is in the form of this, so from this form you know that the minimum point, so because coefficient of x is positive, so the graph should be open upwards, it's positive, so therefore you can find that the minimum point of this you can see from here. When x plus 3 equal to 0, then I have negative 3, so negative 3 and negative 5. So this is the minimum point. And then what else to look at? Okay, so you find the x-intercept. X-intercept can be found by substitute fx equal to 0. So from here, what do you get? So you get 2x plus 3 squared minus 5 is equal to 0. So you will get 2x plus 3 squared is equal to 5. X plus 3 squared is equal to 5 over 2. So finally you get x is equal to negative 3 plus minus square root of 5 over 2. So you can use your calculator to find the value of x. Then you will get two values, negative 1.419 and another one is negative 4.58. Now you can sketch the graph. So you have, this is the y-axis and this is the x-axis, and then the graph should be less than negative 3. So you can draw dotted line here. So this is negative 3. Your graph should be at the left hand side of negative 3. And then what else do you have? So you have the minimum point is negative 3, negative 5. So let's say this is negative 5. So this is the minimum point. And then the x-intercept is actually negative 1 point something. Okay, you can ignore that because it's less than negative, it's greater than negative 3. But just take this one. So you have negative 4.58. So this is the graph. Okay, so this is the graph. So this should be negative 4.58. Okay, now you can sketch the horizontal line to test whether this function is one-to-one function or not. So see, you have only this horizontal line test show that it cuts at only 1 point. So you can write here by horizontal line test, it cuts at only 1 point. Now let's find the expression of f inverse. So you are given fx is equal to 2 x plus 3 squared minus 5. So this is for x less than negative 3. To find the f inverse, so you can use the properties of f inverse of x should be equal to x. So from there you can get, so you substitute f inverse into the function f, then you get 2, and then you have f inverse of x, and then plus 3, so this is all squared, minus 5 equal to x. So from here you will get f inverse of x plus 3, and then here squared is equal to x plus 5 over 2. So since x less or equal than negative 3, so you must take the negative sign of set x plus 5 over 2. So therefore you can write f inverse of x plus 3 is equal to negative square root of x plus 5 over 2. So therefore f inverse of x is equal to negative 3, comes from here, negative 3 minus this one, x plus 5 over 2. So this is the expression of the f inverse. So we have done with A, we have answered this one. Now let's look at B. So we want to find an inverse for G composite f of x. So as before, so we have G f of x. So f of x is equal to 2, so you have you have big bracket here, x plus 3 squared, x plus 3 squared minus 5. So this is the f of x. So you have to substitute this into G. So you can write as square root of, so 2, and then x plus 3 squared minus 5. So this is the x, substitute x, and then you have plus 5, and then all divided by 2. So from here you'll get, x plus 3. So this one can be cancelled off like this. So you get x plus 3. So this is the expression for G composite f. So class, you can have a try on number 8 and number 9 on your own.